Welcome back to some more geometry. Today, we're talking about volumes of prisms and pyramids. All right, so up to this point, we have looked at surface areas of these. Now, we're looking at the volumes. Now, prisms and pyramids are called polyhedrons. They're called polyhedrons because they have flat edges and flat all the way around, all the flat sides. When we get to 11.7, we talk about cones, cylinders, and spheres, and they're called non-polyhedrons because they're missing what? The flat edges, and sometimes the flat surfaces as well. So that's what makes them unique, but the idea behind them is all the same. So here we have what we call a triangular prism. It's called a triangular prism again, class. Why? Because of the base. The base kind of names them. So in our example here, first off, let's talk about the formula for the volume. So the formula for the volume is area of the base, that's what the big B stands for, times the height of the prism. All right, so let's kind of decipher that. So the base will change. That's what changes. Like right here, we had a triangular prism. Here we have a trapezoidal prism. We say, all right, so how do we find the area of our trapezoid? Remember, this goes back to earlier in this chapter where we had base 1 plus base 2 times the height of the trapezoid divided by 2. So the idea of this height is very similar to the other one. So this all right here stands for big B. That's the area of the base. Now, H is the height of the prism. The height has to be perpendicular, that's what the upside down triangle, to both the bases. Perpendicular there, perfect. This is the height right here, the 10. So our H here for us is 10. But let's look at the base here, our trapezoid. So in our trapezoid, we have, if we remember the formula, it's base 1 and base 2. Base 1 and base 2 are the two parallel sides. The height is, again, the same thing, the perpendicular distance between those two bases. So when we do this problem, we would do 12 plus 6, and this is going to be times our height, 4 all over 2. And then that is all times the height of the entire prism to give that third dimension. Because understand, the reason solids are the way they are is because they're three-dimensional. So this is a two-dimensional figure, area of the base, but then we add that height, gives that third dimension. That's why as we go through this, everything's going to be in forms of cubes instead of squares. All right, so 12 plus 6, that gives me 18. That's 18 times 4 over 2 times the height of the whole thing. I'm going to reduce this. 2 goes into 18. So I get 9 times 4, I get 36, and that's going to be times 10. My final answer is 360 units cubed, right there. All right, so let's go over that again. When we did this, we did the area of the entire base. So the area of the entire base and then times the height. It's almost like we took that base and just stretched it out 10 units to make a three-dimensional figure. Let's try the same problem again, but now we're going to look at a different prism. So this is a triangular prism. Again, why is it called a triangular prism? Because of the triangle. Yeah. So again, volume equals area of the base times the height. The base is a triangle, so we do the triangle formula, which is base times height divided by 2. And then that's going to be times the height of the entire prism. So here's our 90 degrees, so we can go ahead and call this our base and our height of the base of the triangle. So we got 12 times 10 over 2. And then the height of the entire prism, remember, it's the perpendicular distance between the two bases. Well, if this triangle is right here and this triangle is over here, where's the distance between them? Oh, it's the 20. Here's our right angle right here. Here's our right angle right here, so it's perpendicular to each other. So that means the distance, the height of the prism is 20. So it's very easy to understand the height going up and down, like in our last problem. But on this one, we see it side to side. Like, well, that's not right. I remember when we were going through this in class, a lot of people said this was the height, but that's the height of the base, not the height of the prism. Again, the height of the prism is the perpendicular distance between the two bases. All right, so we got 12 times 10 divided by 2. Let's reduce that. So we get 60 times 20. So you multiply those two, get 1,200. All right, again, this is units cubed because it is volume now. All right, that's our first polyhedron. Let's look at our next one right here. Our next one is a pyramid. So pyramids and prisms are very much the same. They're very much the same as far as they have the same base. They also have a perpendicular height, but the biggest difference is on a pyramid, it only has one base instead of two. Now the idea is this kind of still comes off the same shape. So if I were to fit this pyramid inside this prism, you'll see it doesn't take up as much space as the prism does. It takes up, to be exact, a third of the space. So the idea, we use the same formula, area the base times the height, but we're going to divide that by 3, because think about this. Look at all this empty space all the way around, because the prism is only touching around the base, the bottom of the base, and then this one spot right here. Everything in between is just empty space. So there's a lot more empty space than there is space taken up. You can, and the idea, if you really want to try this yourself, find a pyramid that has the same base as some sort of prism, and then fill this up with water. Put a bunch of water here, and then pour it into that one. It's going to take 3 full pyramids of one to fill up the prism of the other one. So kind of see the science behind that. All right, so let's look at our example here. We're going to take 35 by 35. So if it's 35 by 35, what kind of shape do we have here, y'all, as a base? Again, it's a square. So we can say, all right, area of the base is side times side. And we're going to take that times the height of the whole thing. Well, there's 2 heights. Remember, we have the slant height and the altitude height. We've used the slant height previously for surface area. We don't use it for this one. For this one, we are using the altitude height. Remember, height inside, volume, height outside, surface area. So S times S times 55. So our 2 sides right here is 35 by 35. So we'll do 35. 35 times 35. And that is all times 55. And then that's all divided by 3. Because again, it's a third amount of space. So 35 times 35 gives me 12. There you go. 1225, that's times 55 over 3. So we're going to go ahead and multiply that times 55, get a pretty big number. We get 67375, all divided by 3. We're going to go ahead and divide that by 3. You get a rounded decimal, so we're going to go ahead and round that off to 1 decimal. You get 22,458.33, or just 3. Again, this is volume, so it's units cubed. Here's a smaller one. So try this one on your own. See if this works. Go ahead and pause it and then try it. So hopefully you just saw this. Again, our volume formula is area of the base times the height divided by 3. So our base, again, is a square. So it's a side times side problem times the height of the whole thing. So we're doing 4 times 4 times our height. Which height are we using? The 6 or the 5, class? It's the 5. Remember, we're doing altitude height since it's volume. All over 3. So we end up getting 16 times 5 over 3. 16 times 5 gives us 80. So we got 80 over 3. Now, this is the exact answer since 80 is not technically divisible by 3. But we're going to go ahead and round it off to 1 decimal. So we'll take 80 divided by 3. You get 26.66 or 0.7. And this is units cubed. All right. So let's kind of put it all together. So here we got a composite figure. Remember, composite figures are figures that are made up of more recognizable figures put together. So let's look at this right here. We have a prism, our prism right here. So the formula for a volume of a prism is area of the base times the height, okay? And then we got a pyramid. And the pyramid, remember, is area of the base times the height divided by 3. So let's start with the prism down here. We'll kind of work this out. So let's look at our area of the base. We go ahead and set that this bottom square is our base. Right here. Now, if you look at it, it doesn't look 6 by 6, but it is 6 by 6. That's what we're going to go with since that's what they're telling us. So if it's 6 by 6, this is also a square. So remember, area of our base. And I'm going to do it in different colors so we don't get mixed up. Base and height. Area of our base is side times side, or 6 times 6. And then the height here, again, is the distance between here and here. So in this case, it will be 3. All right. So 6 times 6, 36 times 3. We multiply 36 times 3, class. What do we get? 108. So we got 108 inches cubed for the area of the prism. Now let's do the pyramid. So look at this pyramid now. So here, we do have the same base. So we can say, hey, that's going to be 6 times 6. What we're lacking is the height. We don't have the height. We have this 5 right here, but that's not the height. Remember, our height is perpendicular. It goes straight up and down. So what we're going to have to do is make a right triangle right here. Say, all right, we're going straight up and down and then to this slant height. So in this case, we make a little right triangle, and then this now becomes a Pythagorean theorem problem. So this is our hypotenuse, making this our leg in our leg. So what is this? What's the distance from the middle to the edge? Well, if this whole side is 6 and this is halfway, making that 3. So as we set this up, we'll say, all right, 3 squared plus, we'll call this b squared equals 5 squared. So let's work that out, class. So we got 9 plus b squared equals 25. We subtract our 9s. B squared equals 16, and we square root both sides. We find our height to be 4. Perfect. So let's put that in here. We got 4, so we got 36 times 4 over 3, and this does reduce that right there. So we end up getting 12, and then 12 times 4 gives us 48 inches cubed. Now that's the two individuals, but the question is, what's the volume of the whole figure together? Well, we're going to add our 108 to that. So we got 108 plus 48. We end up getting 156 inches cubed. You'll have a few of these in your homework, but hopefully that helps y'all, and have a great rest of your day. Bye.